Define limit formula. Let f of x be defined in an open interval containing a, except possibly at a, or with a possible exception at a itself. This means that f of a may or may not exist, meaning f will have function values at every point in the interval except when it is at point a, but it may also have a function value. And let L be a real number. If all values of the function f of x approach the real number L as the values of x approach the number a, then we say that the limit of f of x as x approaches a is L. In symbols, we write it as the limit of f of x as x approaches a is equal to L. As x gets, so in other words, we say that as x gets closer to a, f of x gets closer and stays close to L. So this is governed by two basic limit laws. We have the limit as x approaches a of x is equal to a, and the limit as x approaches a of c is equal to c, where c is a constant or any real number. Okay, so let's observe the limit of x as x approaches a is equal to a. This is an identity function, meaning whatever the value of x is, that would also be the value of y. So let's observe the table of values. Of course, we get the values from the left and the values from the right. So as you observe the values, as we move our values from a minus 1 to a minus 0.5 to a minus 0.1 until a minus 0.001. So the values of our x are approaching a from values that are less than a. Then it follows that the values of our x was also approaching a. On the other hand, on the right hand side, as we decrease the values of our x from a plus 1 up to a plus 0.001, the values of our y is also approaching a. So we say that from the left side, the limit of f of x as x approaches a from the left is equal to a. And from the right side, we have the limit of f of x as x approaches a from the right is equal to a. So both the left hand and the right hand limits are equal. So we say that the limit of x as x approaches a is equal to a. So this is the identity function. So let me show you some examples. So the limit of x as x approaches 0 is 0. The same thing when x approaches 5 is equal to 5. The limit of f of x as x approaches negative 3 is negative 3. The limit of x as x approaches 100 is 100. And the limit of x as x approaches negative 45 is 45. So when you have an identity function, the limit is just equal to whatever value your x is approaching to. The other theorem is a constant function, meaning whatever the value of x is, your y will always be fixed. So for this case, our y is equal to c. Again, let's look at the table of values. So from the left and from the right. If you observe from the left, as we move the values of a from a minus 1 up to a minus 0.001, meaning we move the values from the left, getting closer to a, our function values never change. It was always equal to c. The same thing happens if we take values from the right of a. The function values never change. Therefore, it is constant. That's why it's called a constant function. So we say that the limit of c as x approaches a from the left is equal to c, And the limit of c as x approaches a from the right is equal to c. So we say that since both functions, since both limits are equal, then the limit of the function is as the limit of the constant function as x approaches a is equal to c. So let's look at some examples. The limit of 5 as x approaches 0 is 5. The limit of 0 as x approaches 5 is 0. The same thing with negative 1 as x approaches negative 3 is still negative 1. So whatever the value your x is approaching to, it doesn't change the function value since we have a constant function. There. So let's do a recap. For the basic limit laws, if we have an identity function, the limit of x as x approaches a is equal to a. And if we have a constant function, then let's say the limit of c as x approaches a, where c is a constant, is equal to c.